Photoelectric effect is a process in which electromagnetic waves, when they strike on the surface of metal, and if they have a certain frequency or higher frequency, they can make the electrons come out. These coming out electrons are called photoelectrons. This process is called photoelectric effect. And the motion of those electrons produces a photoelectric current. Now, metal to metal, it varies what should be the minimum frequency that can make the electron come out. If we want to define this thing, for any particular frequency, any particular metal, there will be a threshold frequency, which is the minimum frequency to make the electrons come out. And every metal has its own threshold frequency. Threshold frequency is the minimum frequency of minimum frequency of a photon that can bring an electron out from a surface with zero kinetic energy. Like it is just enough to make the electron come out. It is not enough for electron to move around. It is just enough for electron to come out. Now, threshold frequency has a symbol F naught, and by now we have discussed different formulas that can connect a frequency or equivalent, find for every frequency we can find equivalent energy of photon. So here's the same thing in a different way. If threshold frequency is the minimum frequency, the minimum energy to do that is called work function. Minimum energy to bring an electron out from the surface with zero kinetic energy is called work function. Both of the definition, they sound almost same. They are actually exactly same. Only difference is one is explaining the frequency that can bring the electron out, and other one is giving you the amount of energy that can bring an electron out. And this energy belongs to a single photon's energy. So if you have a photon with the work function, it can bring the electron out. Okay, and work function is minimum energy that a photon needs to have so it can be absorbed by the electron, and that electron can come out of the surface of the metal with zero kinetic energy. So work function has a symbol phi. Planck constant times threshold frequency gives you work function. So
Okay,
what happens if frequency is more than threshold frequency? If frequency is equal to threshold frequency, then electron will come out with zero kinetic energy. But what if frequency is beyond threshold frequency? It is more than threshold frequency. Then electrons will come out with range of kinetic energies. Okay. Still,
okay, sir.
the minimum kinetic energy will be zero, but maximum kinetic energy will depend on how much energy you provide and what is the work function of that particular metal. All the additional energy will become kinetic energy. If you have, like, for example, there's a work function of 10 and you provide 10, then electron will come out with no kinetic energy. But if you provide 12, then electron will come out with an energy of 2. Okay, so if you provide energy beyond work function, then electrons, they will come out with range of kinetic energy. Here is the summary of this, whatever I said. If frequency is less than threshold frequency, no matter how intense the electromagnetic wave is, how intense the radiations are, how many photons you send, not a single photon, not a single electron will come out of the metal surface. If frequency is less than threshold frequency, not a single photon, not a single electron will come out, regardless what intensity you use, how many photons you send. Okay. What if frequency is
Okay, sir.
equal to threshold frequency? If frequency is equal to threshold frequency, then electrons will come out immediately with no kinetic energy. Like electrons will not have any kinetic energy, and they will come out of the surface. Those photoelectrons coming out with zero kinetic energy because we have just provided energy which is enough for electrons to come out, no additional energy. What if the frequency is more than threshold frequency? If frequency is beyond threshold frequency, then electrons will come out with range of kinetic energy. It is important for you to understand that why the electrons are coming in with range of kinetic energy. Still, minimum kinetic energy will be 0. Maximum kinetic energy will be K max. Look, some of the electrons are coming right from the surface. As you can see, electron number 1, which is not labeled as 1. This one. It is coming from the surface. So it absorbs a photon, which is beyond threshold photon. It is a more energetic photon than threshold photon. You can see electron comes out with maximum kinetic energy. But what if electron is coming from the deeper layers of metal? Then electron will be losing some of the energy to come out, and then further energy will be there for the electrons to move on. But still there will be one particular depth. If electron comes from there, it will come out of the surface with zero kinetic energy. Does this make sense? Because some electrons which are on the surface, they gain energy and they come out with more energy. And electrons that are deeper, electrons that are on the surface, they come out with more kinetic energy. Electrons that are in deeper layers of metal atoms, they come out with smaller kinetic energies, and there will be one particular depth at which electrons will come out with no kinetic energy at all. So still, kinetic energy will have a range from 0
Okay,
to
sir. Makes sense.
0 to maximum. Now, how
So
can
could
we
you just show that?
find? I show what?
Just the diagram on the top. It wasn't in the notes you sent.
Okay, you mean this one?
Yeah, this. Let me just take a picture once again.
Okay, the reason of giving you a photocopy PDF is that you can just fill that empty space by yourself.
Yeah, no, no. वो मैंने miss करी थी ना, as you said, so I didn't know that there was.
Okay.
I'll just copy it.
Okay. Did you take the screenshot?
Yeah, I did. Thank
Good. Now, how can we find the maximum kinetic energy? Maximum kinetic energy will be the energy that you supply minus the work function. You supply HF, HF naught is the work function. So HF minus HF naught is the surplus energy. And that will be the maximum possible kinetic energy. Okay. Any confusion?
No, sir.
Okay. Now, here is an illustration of what we have just learned. The kinetic energy of the photons will have a range and known as K minimum to K maximum. K minimum will be 0 and K maximum will be HF minus HF naught. Maximum energy equals to energy provided minus work function. K max equals to E minus pi. K max equals to HF minus HF naught. H can be taken as common, so it is F minus F naught into H. H C into 1 over lambda minus 1 over lambda naught. Like if we have to introduce lambda into the situation, then lambda will be C over F. Okay, so F will be C over lambda. So we can replace every C with every F with C over lambda. Sorry for the twist. Now, every F can be replaced with C over lambda. We, 1 over lambda naught means maximum wavelength that can produce the photoelectric effect. Remember, when the frequency will be minimum, then wavelength will be maximum. They are inversely proportional. So when we say lambda naught, it is the maximum wavelength of photon that can bring an electron out with zero kinetic energy. And every wavelength which will be less than that will definitely have more energy. Okay.
Yeah, okay.
Same thing can be said in different ways, and it is very important. Kmax equals to mx plus c. So if I have kmax on y-axis, y equals to mx plus c is a equation of a straight line. If y equals to mx plus c and kmax equals to hf minus phi, when I compare these two, on y-axis I have kmax, on x-axis I have f. So x is f, kmax is y. You can clearly see m will be h. So gradient will be Planck constant, and y-intercept will be negative work function. If y-axis is kmax and x-axis is frequency, then this is the kind of graph you should be expecting. Why there is no photoelectron in this region? So if frequency is less than threshold frequency, no electron comes out. If frequency is less than threshold frequency, no electron. So when you go to the threshold frequency, electron come out with zero kinetic energy. And if you start to increase frequency beyond threshold frequency, you can see electrons are coming out with range of kinetic energy. Every metal, metal 1, metal 2 has its own threshold frequency. Every metal has its own threshold frequency, and this can be used as a signature of the metal. Every metal has a specific discrete number as its threshold frequency. Okay. So when we provide that frequency, electrons come out with zero kinetic energy, and if we increase the frequency beyond threshold frequency, then electrons starts to come out with the range of kinetic energy. And on y-axis, we don't have kinetic energy of the electrons. We are having maximum kinetic energy, maximum possible kinetic energy. For this kind of graph, you might have to use this graph to find different things. Number one, you should know that for graph where y-axis is kmax and x-axis is frequency, gradient will be Planck constant, y-intercept will be negative work function, and x-intercept will be threshold frequency. Okay, so this is what you should remember. You should know. Now, what if we have y equals to mx plus c compared with kmax equals to hc into 1 over lambda minus phi. And this time, x-axis will be 1 over h, 1 over lambda. So in this case, gradient will be Planck constant into c. Gradient will be Planck constant into c, and y-intercept will still be the work function, a negative over work function. And this graph is more common than the previous one. Because in this graph, examiner can check one more thing, that can student relate that f is c over lambda or not. So that's why in this case, the gradient will not be Planck constant. It will be the product of Planck constant and speed of light. So if you need Planck constant, you can do gradient divided by C. Y-intercept will be the negative of work function. X-intercept will be 1 over lambda naught, which means 1 over threshold lambda. And threshold frequency will be, you can multiply X-intercept, which is 1 over lambda naught into C. Okay? Confusion?
No, sir.
Okay, let's solve some questions. No, here we go. Describe photoelectric effect. When photons of certain frequency or higher are fired on a metal surface, electrons come out of the surface with different kinetic energies. This phenomenon is called photoelectric effect, and escaping electrons are called photoelectrons. Okay. Now, data work function 5, 4, 2 metals are shown. Sodium is 3.0 into 10 to the power minus 19, 5.8 into 10 to the power minus 19 for zinc. The wavelength of 420 nanometers is incident on the surface of each of the metal. What is meant by photon? It is again a very, very favorite question of the examiner. Answer is discrete quantum packet of electromagnetic energy is called photon. Calculate energy of the photon incident. So can you calculate energy of photon if I give you that lambda equals to 420 nanometer? Can you use this to find out energy?
Yes, sir. E is equal to hc over lambda.
E equals to hc over lambda. Good. So it will be Planck constant 6.60 into 10 to the power minus 34 into 3.0 into 10 to the power 8 divided by 420 into 10 to the power minus 9, or 4.2 into 10 to the power minus 7. So can somebody calculate? I do not have a calculator right now.
Yes, you give me a second. 4.735 times 10 to the minus 19.
4 point
74 times 10 to the minus 19.
Okay, this is the energy of this photon. Do you think it can cause photoelectric effect in sodium? Listen, sodium requires an energy of 3.8 into 10 to the power minus 19. Do you think the energy that we have calculated can cause photoelectric effect in sodium?
So could you slide it up?
Hmm, I thought you had PDF with you in the printed form. So this photon's energy is 4.7 to 10 to the power minus 19. Sodium requires a minimum energy of 3.8 into 10 to the power minus 19 for photoelectric effect, and zinc requires 5.8 into 10 to the power minus 19 joule of energy for photoelectric effect to start happening. So in which metal you think photoelectric effect can happen?
Zinc.
Good. And why?
Uh, it is because the energy we have calculated uh, can easily dissipate electrons.
Oh, so you think that 4.7 is more than 5.8?
Sorry.
Oh, zinc requires a minimum of 5.8. Let's ignore 10 to the power minus 19 because it is same for everything. So zinc requires an energy of 5.8. Sodium requires a minimum energy of 3.8, and we have 4.7.
So sodium will emit and zinc won't.
Yes, photoelectric effect will happen with this photon. Photoelectric effect can happen in sodium, but cannot happen in zinc. Whether the photoelectric effect will occur with each of the material, sodium, yes. Zinc, no.
Sorry, sir, I got confused in that 10 to power minus 19.
Energy of photon is more than work function. Energy of photon is less than work function. See, for zinc, it is less than work function. For sodium, it is more than the work function. So does this make sense?
Yes, sir.
Yes.
Good. There we have. By the reference of threshold, by the reference of photoelectric effect, state what is meant by threshold frequency. Minimum frequency that can liberate an electron from surface of metal with zero kinetic energy is called threshold frequency. Okay, this is straightforward definition. We just discussed this. Electromagnetic radiation wavelength lambda is incident on the metal surface. Electrons of maximum kinetic energy are emitted. On the figure, sketch the graph of this. Okay, this is the kind of graph that he's looking for. That's it. Okay. Because this will be the threshold, 1 over threshold wavelength. And so on. State an equation relating the gradient of, oh, he has simply asked for this thing.
Sir, energy and wavelength is inversely proportional, right?
Yes. Gradient equals to Planck constant multiplied by speed of light. Okay, we just did this thing. If the graph is Emax and 1 over lambda, then the gradient will be Planck constant multiplied by speed of light. If it would be Emax and F, in that case, gradient would be Planck constant. Explain why for any particular wavelength of electromagnetic radiation, most of the electrons are emitted with kinetic energies less than the maximum value. Most of electrons come from deeper parts of metal and they lose their kinetic energy while reaching the surface. Hence, most have energies less than Emax. Okay, less particles or less electrons come from surface and more come from the deeper layers. So more have less energy. Light of particular wavelengths is incident on metal surface and gives rise to the photoelectric current. The wavelength is reduced, the intensity of the light is kept constant. Extend and explain, if any, on the photoelectric current. Wavelength is reduced means frequency is increased. Frequency increases. Each photon has more energy as intensity is fixed. So less photons are available. Now, electrons come out with higher kinetic energy, but less photoelectrons are observed. So photoelectric current decreases. Actually, when wavelength is reduced, it means photons energy is increased. But he has kept the intensity constant. It means the total power is same. So if power is same and each photon has more energy, it means the number of photons should decrease. And if there are less photons, there will be less photoelectrons, hence there will be less photoelectric current. Okay. So you can solve more questions with energy levels and photoelectrons by yourself and discuss the problems tomorrow. Tomorrow we'll start X-rays.
Sir,
Yes.
please ये वाला PDF भेज सकते हैं?
Okay.
Thank you so much.
Okay. See you people tomorrow.
All right, just now. Have a nice day.